In this video, we're going to be talking about finding the zeros of a polynomial, but first we should talk about what a polynomial actually is. So a polynomial is a function where each term is raised to a non-negative integer. So that means we got functions like, hold on one sec. We have functions like, let's say y equals 4x squared plus 3. All the exponents are non-negative, means they're not negative. They can be 0, but they're also integers, so no fractions. So an example of one that wouldn't be a polynomial would be y equals 4 times the square root of x, or y equals 3x then negative squared, and so on and so forth. So basically a polynomial is a function where the exponents are non-negative and integers. So it rules out square roots, negative numbers, and so on and so forth. Zeros of a function are values of x that make the function equal to 0. These are going to be called roots, and these are all pretty much saying the same exact thing. X equals a is a root or solution, same thing. We can write them as factors of a polynomial. So if a is a root or solution, x minus a is going to be a root. It's going to be a factor. And last but not least, if it is a root or solution, the x-intercept is going to be the value of x and 0. Next we're going to find the zeros of a polynomial, and eventually we're going to be able to graph these guys. Here we have find all real roots of f of x. Now they say real roots, so if we have a root that turns out to be imaginary, we just exclude it. We can't graph imaginary numbers. So let's find all the real roots for f of x. So first we look at if we can factor anything out. Is there anything in common between x cubed, 7x squared, and 12x? Well, we see they all have an x, so let's just factor out that x. Now we have a quadratic on the inside here, so I'm going to try and factor that, or we can use the quadratic formula if you don't want to factor. It's your choice. But it is pretty easy to factor it, so I'm just going to do x plus 4, x plus 3. Now to get those, we're looking for factors of 12 that add up to 7. So 4 times 3 is 12, 4 plus 3 is 7. Now we're trying to find the roots or solutions, so that means the equation has to equal 0. Now thinking back to algebra 2, where if we have numbers being multiplied to equal 0, either both of them or one of them need to equal 0. So we do x equals 0, x plus 4 equals 0, and x plus 3 equals 0. And now we just solve for x. Well, this one's already solved for, so x equals 0, that's done. So then we got to solve for x here, so x equals negative 4, and then x equals negative 3. So our roots for the function is x equals negative 4, 0, 3. You can just see it as written as x-intercepts as well. So let's say x-intercepts are 0, 0, negative 4, 0, and 3, 0. Okay? You might also see problems similar to this. It says determine the polynomial given the zeros. So basically what we're going to do is we're going to split these into factors. So you saw on the first slide and the second slide, we broke the equation into factors. So basically we'll have, if we're given a 0 of a function, we know one of its factors is x minus that number. That's one of the factors. So we're given 4 factors here, so we're going to split the polynomial into factors pretty much. So f of x, let me change the color. F of x equals x minus one of our factors, so let's say x minus a negative 2. That's one factor. And our second 0 is x minus 0. Alright, so I just create a polynomial with all of our zeros written as factors. Now we're just going to simplify it a little bit to make it look nice and pretty. So x minus negative 2 is the same thing as x plus 2. x minus 0 is the same thing as x. X minus 1, x minus 3. Now, we could distribute all this and complicate things, but I think this is as far as we'll take it. So this is our polynomial, or in factored form. If it asks for the possible degree, you would just see how many x's you have. You have 1x, 2x, 3x, 4x's. So our degree would be fourth degree. Alright, after watching this video, I think we could do a couple practice problems. Let's do page 267, numbers 37 to 40.